Hey everyone, welcome to today's video where we're going to be discussing one of the most fascinating topics in theoretical physics, string theory. If you're someone who's interested in science and physics but has never really delved deep into the realm of quantum mechanics, then you're in the right place. In this video, we'll be exploring the basics of string theory, how it works, and why it's such an important concept in modern physics. So let's start with the basics. What exactly is string theory? At its core, string theory is a theoretical framework that aims to explain the fundamental nature of matter and the universe as a whole. It proposes that at the most basic level, everything in the universe is made up of tiny, one-dimensional objects called strings. These strings vibrate at different frequencies, and it is these vibrations that give rise to the various particles that make up the universe. Now you might be wondering, why strings? Why not some other fundamental object? The answer lies in the fact that strings provide a way to reconcile the two pillars of modern physics, quantum mechanics and general relativity. Quantum mechanics deals with the very small, the subatomic particles that make up the universe. General relativity, on the other hand, deals with the very large, the structure of space-time itself. String theory provides a way to unify these two theories by proposing that everything in the universe, from the smallest particle to the largest galaxy, is made up of strings. One of the most fascinating aspects of string theory is that it requires the existence of extra dimensions beyond the three spatial dimensions and one time dimension that we are familiar with. In fact, string theory requires the existence of 10 dimensions in total. These extra dimensions are curled up or compactified, meaning that they are too small for us to detect directly, but their presence is required for the math to work out. This may sound confusing, but think of it like this. Imagine an ant walking along a tightrope. To the ant, the tightrope appears to be one-dimensional, but to us, who can see the tightrope from above, we can see that it has a second dimension. Similarly, the extra dimensions in string theory are hidden from our direct perception, but their existence is required for the theory to work. Now, you might be thinking, this all sounds very interesting, but can we actually test string theory? The answer is not yet. Unfortunately, string theory is still a purely theoretical concept and has yet to be experimentally verified. However, that doesn't mean that it's not a valid and important area of study. Many scientists believe that string theory has the potential to provide a complete and consistent theory of everything, but we still have a lot to learn about the universe and how it works. That being said, string theory is not without its controversies. Some physicists argue that it's not a scientific theory at all, as it cannot be experimentally tested. Others criticize it for being too abstract and for making too many assumptions about the nature of the universe. However, despite these criticisms, string theory continues to be an area of intense research and debate within the scientific community. So, what are the implications of string theory? Well, if string theory is correct, it would open up a whole new world of understanding about the nature of the universe. It could potentially lead to the discovery of new particles and phenomena that we have yet to observe, and it could provide a way to reconcile some of the most fundamental questions in physics, such as the nature of gravity and the origins of the universe. But even if string theory turns out to be incorrect, the pursuit of this theory has already led to many advancements in our understanding of physics. It has inspired new mathematical techniques and helped us to develop a better understanding of the nature of the universe at the most fundamental level. So there you have it, a brief introduction to string theory. While we've only scratched the surface of this complex topic, hopefully this video has given you a better understanding of what string theory is, why it's important, and some of the controversies surrounding it. As always, feel free to leave your comments and questions below, and we'll do our best to address them in future videos. Thanks for watching.